Okay, so today we have an epsilon delta proof for a linear limit. So in this proof, we have to prove that the limit of f of x, which is 3x plus 5 as x approaches 5, is equal to 20. So let's go ahead and define this with our definition. So for every number of epsilon that is greater than 0, so a positive epsilon, there is a number delta such that if basically the absolute value of x minus a, which is greater than 0, is less than, oops, I forgot to write it, is less than delta. Sorry about that, delta. Then the absolute value of f of x minus L is less than epsilon for the limit of f of x as x approaches a is equal to L. So what does that mean? Basically what this is saying is that, hold on, let me show you something. What this is saying is that as x gets closer and closer to 5, so this is our x values. This is a very rough sketch of our function, f of x. So as x gets closer and closer to 5, our function will take our values closer and closer to our limit of 20. That's basically what this is saying. That's basically what this is telling us. So we can get super close to 5, 4.99999, and it will get us super close to our limiting value of 20. Again, super close to 5, we are going to get a value close to 20. So that's basically what this is telling us. So as x gets closer and closer to 5, our function takes our values closer and closer to our limiting value, which is 20. That's basically what this is telling us. So let's go ahead and prove this. So yeah, by the way, these are absolute values because it represents distance. We cannot have a negative distance, therefore we have absolute values. So let's go ahead and prove this. So given that epsilon is greater than 0, we need to find a delta. We need to find delta. Well, we need to choose one so that this one 0, x minus a, which is our a. According to our definition of the limit, this is the a value, so the 5 is going to be our a value. X minus 5 is less than delta such that f of x, which is our f of x is basically the function 3x plus 5. 3x plus 5 minus our limiting value. What's our limiting value? It is 20. It's less than epsilon. So yeah. So given that epsilon is greater than 0, we need to find delta, or a delta. Choose a delta. You can write whatever. So that the absolute value of x minus a, x minus 5, is greater than 0 but less than delta, such that the absolute value of our function 3x plus 5 minus our limiting value of 20 is less than epsilon. So this is what we need to prove. Or check, whichever you need. What we need to check. What we need to check. And this is our assumption. This, let's say, is our assumption. So let's say that's our assumption, and this is what we need to check. or what we need to check is true. So we can go ahead and do our work now. This is gonna be our section for our work or thoughts, background thoughts. So since this is what we need to prove, what we need to check is true, this is gonna be our assumption, we are going to start with this one, okay? So we have our, basically what we need to check, we have 3x plus 5 minus 20. So that's what we need to check, right? So let's go ahead and do some algebra. So this in turn is going to give us 3x plus 5 minus 20. That's going to be 5, positive 5 minus 20. That's a negative 15, right? 3x minus 15. This in turn is going to give us, oh yeah, I forgot to mention in the beginning. I mean, it's not too late to mention, but our goal is to make this, what we need to check, look like our assumption. We need to make it look like x, the absolute value of x minus 5. Just a heads up, but that's what we're trying to do right now. So now that we have this, let's go ahead and factor out a 3 to make it look like x minus 5, right? Let's go ahead and factor out a 3. 3 times x minus 5. Cool? Because 3 times x is 3x. 3 times negative 5 is 15. I'm just going to assume if you're watching this, you already know how to do basic algebra. So I don't have to explain factoring to you, since I'm going to assume you know how to do it. If you don't, just go ahead and look up other videos. But yeah, this is how, just some basic factoring here. Okay, so now that we factor out a 3 out of the x minus 5, we can take this 3 out of the absolute value because it's positive and absolute value is positive, so it doesn't really matter that much. So let's go ahead and take out our 3. 3 times the absolute value of x minus 5, right? And we see that this looks a lot like our assumption of, let's ignore this for a bit, of absolute value of x minus 5 is less than epsilon, delta. So that looks a lot like our assumption, right? So now that we have our assumption, now we get to choose a delta. So we get to choose a delta. Choose a delta. So now we have, let's go ahead and draw a little arrow right here. 3, the absolute value of 3 times x minus 5 is less than epsilon. That's basically what we need to check. We haven't proved it yet, but that's what we're gonna check. So 3 times the absolute value of x minus 5 is less than epsilon, and we need to choose a delta now. So let's go ahead and choose our delta. Let's just write our little note right here. Choose a delta. That's a horrible looking delta, but choose a delta. So in order, if we want to make this look more like, just let's ignore this for a bit, but if we want to make our what we need to check look more like our assumption of the absolute value of x minus 5 is less than delta, what do you think we need to do to get rid of the 3? That's right, we need to divide by 3 from both sides. These are obviously going to cancel out, and we're left with the absolute value of x minus 5 is less than epsilon divided by 3. Boom, we found our delta that we can use. So let us go ahead and put a little note right here to let delta be epsilon minus divided by 3. Cool, so now we found our delta. Good. So now that we found our delta, now we are ready to do our proof. So let's go ahead and prove it. Let's go ahead and write down another section. Oops, for proof. Proof. Okay, so now that we have our work, let's go ahead and prove it. So let's go ahead and you can re-say the definition if you want, but let's just for the sake of this video, let's go ahead and just, let's go ahead and summarize it. So let's go ahead and suppose suppose epsilon is greater than 0 is given. Oops. Come on, let's go. Is given. And our delta, and let delta be epsilon divided by 3. Good? So now that we have that, let's assume we're going to assume that we're basically going to have to assume that our assumption is true. So assume we are going to assume that this thing that one we just worked out is true, in accordance to our assumption, of course. So we're going to assume that's true. So we want to prove that 3x plus 5 minus 20 is less than epsilon. Right? So that's what we want to prove. So let's go ahead and prove it. Yeah, let's go ahead and prove it right now. So again, we are going to basically write down our work that we did. So it's going to look very similar. This is going to give us 3x minus 15. Turn is going to give us 3 times x minus 5. Very similar to the work that we just did. So now we have that. So, since our assumption of the absolute value of x minus 5, right? Minus 5 is less than delta. Then, okay, so since we already have our assumption, right? We already established our assumption to be the absolute value of x minus 5 is less than delta. So since our assumption of the absolute value of x minus 5 is less than delta, then now we can work with this, right? Now we can work with that. Then 3 times the absolute value of x minus 5, right? X minus 5 is less than, what can we put here? This is our assumption. Pretend there's an invisible number 1 here and an invisible number 1 in front of the delta. 1 times the absolute value of x minus 5 is less than 1 times the absolute value of delta, right? There's only one absolute value here and 1 delta. So if we establish by our work that basically what we're trying to check, this little piece right here, 3x plus 5 minus 20, this little piece is equal to 3 times x times the absolute value of x minus 5. That's 3 times this. What can we put here? That will be 3 times delta, right? That's, again, a horrible looking delta, but that will be 3 times delta. So since our assumption of the absolute value of x minus 5 is less than delta, then 3 times the absolute value of x minus 5 has to be less than 3 times delta, correct? Yeah. So since we chose our delta to be 3 epsilon divided by 3, since our delta was chosen as epsilon divided by 3, then what? Since our delta was chosen as epsilon, as epsilon divided by 3, then 3, then let's go ahead and rewrite this right here. Then 3 times x minus 5, right, is less than 3. What will go in the parentheses? Since we chose our delta to be epsilon divided by 3, we can write the parentheses as epsilon divided by 3. Correct? These two will cancel out and in turn only give us epsilon by itself. Correct? So we have 3x minus 5 has to be less than epsilon if we assumed this was true. Our work was true. Good? Because if we assume our work is true, then we can choose a delta to be epsilon divided by 3. And since we chose delta to be epsilon divided by 3, by our assumption of x minus 5 is less than delta, then our work of 3 times the absolute value of x minus 5 has to be less than 3 times delta, right? If we assume pretty much both our assumptions are true. If we assume this is true and if we assume that is true. So since our delta was chosen as 3 divided by as epsilon divided by 3, then this one has to be equal to, well, 3 has to be equal to our delta has to be equal to epsilon divided by 3. Cancel out the 3. It has to be less than epsilon. So this has to be less than epsilon according to our proof, and we can just work backwards to say that let's say, okay, so we got that. We're not going to work backwards. You can if you want, but thus we can just go ahead and write this. Thus thus 3x plus 5 minus 20 is less than epsilon. If you again do your work, you reverse your work, you're gonna this is obviously gonna equal to this. Cool? So this is obviously going to equal to this, and we still have the minus epsilon. So thus the absolute value of f of x minus 20 is less than epsilon. So now we can finally end our proof. By the definition of a limit, the limit of 3x plus 5 as x approaches 5 is equal to 20 is proven. So that is our epsilon and delta proof for the limit of 3x plus 5 as x approaches 5 is 20. Cool. That is it.